Welcome to the second video of the GPR series. Now you imagine this: you are driving a bike on a smooth highway. Now suddenly, if you enter into a muddy road, you will definitely see that the speed of your vehicle will reduce. Right? The same way, when you are using a GPR, uh, like I told you, the electromagnetic wave is going into the ground and it is hitting something and it is coming back. So when there is a change in the medium, like uh, dry soil, wet soil, or air, the velocity will change in the GPR. So we say that if velocity is changing, then you'll have a lot of difference with the depth also. And this concept is very important because when, like I told you in the previous video, if velocity is wrong, your depth calculation will also be wrong. Now, we have to understand what controls the velocity in the GPR. This is the permittivity. It's not a new term. Permittivity is generally the word itself says that how much material is resisting the electromagnetic waves to pass through them. That means higher permittivity means the waves will travel slower, and when the permittivity is low, then the waves will travel fast. Say for example, in the first part we take the image air. Here the permittivity is low, that means the wave velocity will be fast. So you can understand, lower the permittivity, higher will be the velocity. And when you take dry sand, it becomes slightly slow, but in case of a wet sand soil, the permittivity is very high, so the velocity will go down. And this is the reason why moisture availability in a ground will change the results of GPR. Now, we take some examples, the theoretical example, or the numerical example, then you'll understand clearly. Here, if you see, typically the GPR velocity in the air will be around 0 0.3 meter per nanosecond, and in the dry soil it is 0.15 meter per nanosecond. In the wet soil, it is 0.6 to 0.1 meter per nanosecond. So we can clearly see that more water means lesser the velocity. Now, to solve a simple numerical, we can take the reflection is coming at 80 nanoseconds. So in the first case, like air, I already told you it is, or we can take the dry soil at 0.15 meter per second. So the depth will be 0.5 into the time. Here we are telling the time as 80 nanoseconds. So 0.15 into 80, and we have to divide it by 2. Then we will get the depth of 6 meters. Okay, now let's change only one thing. Suppose the soil is wet and the velocity becomes 0.08 meters per nanosecond. Then depth will be 0.08 into the time is already 80, but so 80 by 2. Then it will become 3.2 meters. See, now just with the change in the moisture content, the depth has changed. Same travel time, but it is completely different with the depths. And this is why velocity estimation is one of the most important part of a GPR interpretation. In the upcoming videos, we'll also learn how velocity is estimated practically, how hyperbolas help calculate the velocity, and why experienced interpreters spend so much time in understanding the subsurface material. So, if you are really interested in learning the GPR properly, please do follow the next videos and do subscribe to Geoscience Engineering channel. Thank you.